Hello and welcome to Colour Multimedia Enterprises. My name is Luke, also known as Tienery, and I am going to be continuing with my Haxe tutorial series, which I revised and sort of revived to a certain extent a couple of weeks ago. And I am going to continue with tutorial 2. And in this tutorial, what I'm going to be basically showing you is the difference between classes and typedefs, when to use each one, and what the performance benefits of either one of them are. Now, there obviously this is going to be a bit biased considering I'm only going to be using one target for this. I could show different targets, but I haven't quite figured out a way to do a performance breakdown on a JavaScript target, which would probably be a good idea to try and research. We could take a look into that, but for the time being it's just going to be Neko, possibly C++, and maybe one or two other targets, not entirely sure yet. But point is that in this tutorial we are going to be taking a look at both classes and typedefs. So I am just going to delete this class because I no longer need it. That was part of a different tutorial. So what I'm going to do is create two things. I'm going to call this my class. That is going to have a few variables in here. So basically we're just going to be taking a look at the differences between typedefs and classes, when to use each one. C int and public var d int, like that. Okay. And what you can also do, I don't know what I'm talking about. Typedef, my typedef, there we go. And in this typedef, what I'm going to do is put in some variables here. Var a int. Now, I'm using this optional meta tag here. You're probably wondering why. The reason why is because in order to construct a typedef, well, it's not really constructing, it's more like declaring or initializing. I'm not entirely sure on the specific terminology that Haxe uses in its manual, but the way that you create a typedef is like this. So you would do my typedef like this, right? And the way you declare it is like that, right? So that's an empty typedef. So that's me initializing it. Now, obviously I can access things like A, B, C, D, right, as you would a class. But the difference is that if I put optional there, I can omit those in the side of here. Now, the way you can access the member variables within the typedef when you initialize it to start with, you can use the variable name followed by the colon, which basically specifies that you want to assign it a value. So let's say 5, right? And then I trace TPA, right? Which should, in theory, just print out 5. So let's go ahead and just build that. So Haxe build.html. So I'm just going to build that very quickly, and in here I am just going to say Neko main.n, and it prints 5. Now obviously if I were to omit that and build it again, it might come up with an error because Neko doesn't like nulls, and it's null. Yeah. There's a bit of a catch with Neko. Sometimes when you come across null variables, when you build a an OpenFL project, for example, and you leave something null, the Neko application would crash. The reason why is because, like I said, it doesn't like nulls, Now in that instance, because we didn't actually bring up a window, we just brought up a console window, it didn't actually crash, it just printed out null, as you would expect. So it does accept nulls, it just doesn't like it when you try to access something that is null, if that makes sense. C++ is kind of similar. It depends on how you're accessing the variable, but that's a completely different subject, and we'll probably move on to that in a completely different tutorial when we talk more about in depth about each of the different targets, what they do, and how you can leverage the power of Haxe within each of the different targets. But for now, obviously, these tutorials are mainly focused on the Neko target. So let's go ahead and do a benchmark, shall we? So what I'm going to do is I am going to import, there's a specific thing in Neko. I can't remember which one, where I found it. Actually, it's not in this at all. It's not in Neko at all. It's in sys. And it's CPU time. So basically what CPU time does is it gives us a timestamp value in seconds that specifies the amount of time that was spent on the current thread or process. And that's what we're going to be using to determine the speed of the class and the typedef. We might do that for the C++ target. I don't think there's much difference between the two, but we'll go ahead and check them anyway. So what I'm going to do is create an array of classes. So this is going to be array. Actually, I'll do it this way. Array, my class, like that. And then what I'm going to do is say for I in 0 ... say 100,000. So we're kind of stress testing here. So I'll say my class is push. Let's put in 0. No, what am I talking about? No, new. I'll do it a different way. So I'll say var my class. Eventually, when I can type my class. Oh. Now there is a difference, as you could probably see. Now with a class, you have to have a constructor. With a typedef, you don't. So that's one difference. So my class dot A is equal to 50, let's say. My class dot B is equal to 6122. My class dot C is equal to some random high number. And D, I don't think we can do. I think we can do like a max. Normally you can do a maximum integer, but I don't think we've got that. So never mind. I think one of the main reasons why is probably because the int is an abstract, which converts into a specific type depending on the target language. Now normally integers are 32-bit numbers, but C++ is a bit weird because when the compiler checks to see that integer, it basically just assigns, I think it's by default 32-bit, and it doesn't, it's sort of, yeah, I wouldn't be very good at explaining exactly what's going on behind the scenes with compilers, if I may be honest, but the point being is that integers on different targets will probably output different things, which is probably the reason in terms of memory that is. which is probably the reason why we don't have access to the maximum value. We probably could put it in there, but what can you do? It's not there yet, regardless. So we initialize some values, we put that class into those my classes, and in fact what I'm going to do is say last time is equal to sys.cpu time, CPU time, like that. And then what I'm going to do is just say for I in 0.100,000, because that was what we accessed. And then what I'm going to do is just say my classes I dot bd is equal to 60 or something like that. And then we're just going to trace the result. So all I'm going to say is time spent on classes, and then I can do last time. So I'm basically storing this variable, which is going to capture that CPU time. I forgot. One more thing that I needed to do actually is last time sys.cpu time minus last time, because this is kind of like delta time, which is the result we actually need. So this will basically capture the difference between the time it took between the last call of the CPU time to this call of the CPU time. So from line 8 to line 26, all of the instructions between those lines, they will be done, and then the CPU time will be called again. That is then going to be subtracted by the last time, which is probably going to be 0, because obviously that's the very first thing that is called. That being said, CPU time is of course a call which can in itself take some time. So that's that. And then I'm going to do the same for Typedefs. So let's go ahead and change a few things here. My typedef, typedef, like that. My typedefs. My typedef, and it's not like that. It is, like this. Just remember, that's not how you construct a typedef or initialize. I can never really get the variables right, really. And then that needs to be my TP, like that. And that needs to be typedefs. Do the same here as well. And then just do the same thing there as well. And what I'm also going to do is assign last time to delta. So that last time will basically be the time that the CPU time minus the previous last time was going to be, so that we start from line 28 through to line 46 to determine the next amount of time we took initializing and making these typedefs. Okay, so assuming that's all right, I'm going to build it very, very quick. And then what I'm going to do is do that. Oh, typedefs. And I don't think I did that correctly. I'll do delta 2. Delta 2. It's normally a difference. Normally a difference. Not entirely sure why that is. I could do a last time too as well. I wouldn't have thought that would make much of a difference. It could just be the fact that I used the C++ target last time and there was a big difference between them. So it might just be the case that we are working on the Neko target. So what I'm going to do is I'm going to build to the C++ target instead. So Haxe build-cpp.html. So we'll build to the C++ target and see if there's any differences there. Now, at the end of the day, it's just basically testing and seeing what happens. Oh, of course. Might be a good idea just to do that. Right. So as you can see, there's quite a bit of latency accessing typedefs on the C++ target versus classes. But on the Neko target, as you saw, the access time is... Oh, it's different now. Huh. Interesting. Very interesting. So classes are slightly slower to access than typedefs on the Neko target. That's interesting. Very interesting. Okay, so now I'm going to show you the differences between typedef and classes, because that's a nice exercise to do for several reasons. A, you can determine what the best action is for your applications when you program, for when you're creating performance critical applications like video games, for example. And it's nice to know in order to know the differences between the two. Now, on some targets like HTML5, for example, JavaScript, I don't think you have a timer. You might be, I think if you were to create an OpenFL application and you used the OpenFL methods, then in order to mimic this exact code, then it is possible that you could do it there for the HTML5 target and many other targets for that reason. And you could play around with it and figure out what the best way to create things with, if that makes sense. So differences. What are the differences between classes and typedefs? So in classes, whenever you want to create a class, you need to have a constructor. You need to have it. It doesn't matter if it doesn't have one, but you do need one. Another thing is that all of your variables need to have public access, public or private access in some way, shape or form. You need to have that keyword. You can't do that like you can in typedefs. The reason why is because the class is kind of like in object-oriented programming languages, whereby there needs to be some kind of way in which you can access these things. Now, the private keyword in Haxe, it actually behaves more like the protected keyword in C++ and C# and other like languages, in that you can access any private variable if the class is extended, right? So if I were to, let's say, make this private, for example, and I go back to main and I try to rebuild that, it will say cannot access private field A. But if I were to extend this class and say class, my extended class, let's say, and I extend my class, I can now access that in here. That's a variable. So if I call super, because what you need to do in this instance is call super. Super calls this constructor here. So again, in classes, you always need a constructor whenever you call the new function. This is basically the method that you're invoking. Whenever you call super, you are invoking the base class function new, right? If that makes sense. So in here, if I were to make this my extended class now, instead of my class, and I then accessed A in here, made it 10 for example. Now let's take a look at the results first. Oh, oops. There's something I forgot to do. This is the weird thing about Haxe actually. It's kind of annoying, but never mind. So yeah, cannot access private field A. So we still can't access it outside of that scope, regardless, because at the end of the day it is derived from my class. But we can access A in its extended class. So if I were to build that again, it builds without an error, because we can still access that A from within this class. So that's a little bit about classes. Now what about typedefs? Typedefs are, as the Haxe manual puts it, anonymous structures. Now anonymous structures are very, very useful, and they're particularly useful for when you use JSON. Now if you've ever seen import haxe.json, you will probably come across things like json.parse, right? And that returns dynamic. Now what you can do is you can use a typedef to basically not really convert per se, but match the structure of the JSON toward a typedef. So if I had, for example, in my bin folder a text file, and I called it info.json, right? And in that JSON file, what I did was I had an array, and I had A in 1, which is 5, B as another, which is 10, C 15, and D 20, right? So I saved that, and then in my main, what I can do is if I get rid of all of this, what I can do is I can say var my type dot array my typedef json.parse, and then I get the value of that. So I'm going to need import sys.io.file. I'm going to need to get that content. So get content, and that is going to be info.json, right? Now what I can then do is say my type 0.a, right? So I'll just do a trace on that, and that should, in theory, if we go back in here, print 5. So let's go ahead and build that. Built successfully, and now if we go ahead and run it, it prints 5. The reason why this works is because my typedef is the exact same structure as it is in here. And the great thing about Typedefs is that if you were to put these optional tags here, in fact, never mind. I was about to say something, but I'm actually not 100% sure whether I would be correct in saying it, so I'm not going to say it. But basically, the point is that Typedefs can save quite a bit of time when you're dealing with JSON, because as you see, if we hover over this again, it returns a dynamic. Now, a dynamic, as you can see, if you read that, it says parses given JSON encoded text and returns the resulting object. JSON objects are parsed into anonymous structures, and JSON arrays are parsed into array. And as you saw, it was perfectly fine with that array. It was perfectly fine with that typedef, and we were able to access it. So when should you use typedefs and when should you use classes? They are both statically typed. Not statically typed, what am I talking about? Explicitly typed, which means that you still need to specify the values, the types for each of the values within either a typedef or a class. Typedefs are very small. They're normally very cheap on the RAM, but possibly not on the CPU, depending on what target you use. Classes, on the other hand, you need to construct them in order to access any of its members. Sometimes can be slower on the RAM, not so much on the CPU, as we saw. So that's a bit of a tutorial for you for the difference between classes and typedefs and when to use them. Thank you very much for watching, and I will see you next time.